Section 12.4, Protecting and Auditing Data with Spring Security and Spring Data. So far, we've looked at securing the APIs exposed by Spring Boot applications and handling concerns like authentication and authorization. What about data? Once you have Spring Security in place, you can also secure the business and data layers. Regarding the business logic, you can enable the Method Security feature to check for user authentication or authorization directly on business methods, leveraging annotations like pre-authorize. In the Polar Bookshop system, the business layer is not complex enough to require additional security policies, so I won't describe that. Note: to learn more about how to use method authentication and authorization, refer to Chapter 8 of Spring Security in Action by Laurentius Spilka, Manning 2020, where those topics are explained in great detail. On the other hand, the data layer requires some extra work to address two main concerns. How can we tell which users created what data? Who changed it last? How can we ensure that each user can only access their own book orders? This section will address both concerns. First, I'll explain how to enable auditing for users' actions on data in both Catalog Service and Order Service. Then I'll walk you through the changes required by Order Service to keep the data private. Section 12.4.1, Auditing Data with Spring Security and Spring Data JDBC. Let's start by considering Catalog Service, where the data layer is implemented with Spring Data JDBC. In Chapter 5, you learned how to enable JDBC data auditing, and you configured it to save both the creation date and last modified date for each data entity. Building on top of that, we can now extend the audit scope to include the usernames of the person who created the entity and the person who modified it last. First, we need to tell Spring Data where to get the information about the currently authenticated user. In the previous chapter, you learned that Spring Security stores information about authenticated users in an authentication object, which is stored in a security context object available through the security context holder. We can use that object hierarchy to specify how to extract the principal for Spring Data. Defining an auditor to capture who created or updated a JDBC data entity. In the Catalog Service project, Catalog Service, open the Data Config class. That's where we use the Enable JDBC Auditing annotation to enable data auditing. Now we'll also define an auditor-aware bean that should return the principal, the currently authenticated user.
Listing 12.21, Configuring User Auditing in Spring Data JDBC.
Adding audit metadata for users who created or updated a JDBC data entity. When an auditor-aware bean is defined and auditing is enabled, Spring Data will use it to extract the principal. In our case, it's the username of the currently authenticated user, represented as a string. Then we can use created by and last modified by to annotate two new fields in the book record. They will be populated by Spring Data automatically whenever a create or update operation is performed on the entity.
Listing 12.22, Fields to capture user audit metadata in a JDBC entity.
After adding the new fields, we need to update a few classes using the book all-args constructor, which now requires passing values for created by and last modified by. The book service class contains the logic for updating books. Open it and change the edit book details method to ensure the audit metadata is correctly passed along when calling the data layer.
Listing 12.23, Including the existing audit metadata when updating a book.
I'll leave it to you to update the auto tests in a similar way. You can also extend the tests in BookJSON tests to verify the serialization and deserialization of the new fields. As a reference, you can check Chapter 12/12n/catalog service in the code repository accompanying this book. Make sure you update the tests that use the book constructor, or else the application build will fail. Writing a flyway migration to add the new audit metadata to the schema. Since we changed the entity model, we need to update the database schema accordingly. Let's assume that Catalog Service is already in production, so we need a flyway migration to update the schema in the next release. In Chapter 5, we introduced flyway to add version control to our databases. Each change to a schema must be registered as a migration, ensuring robust schema evolution and reproducibility. Any change to a database schema should also be backward compatible to support common deployment strategies for cloud-native applications, like rolling upgrades, blue-green deployments, or canary releases, a subject we'll cover in Chapter 15. In this case, we need to add new columns to the book table. As long as we don't make them mandatory, the change will be backward compatible. After we change the schema, any running instance of the previous release of Catalog Service will continue to work without errors, simply ignoring the new columns. In the src/main/resources/db/migration folder for the Catalog Service project, create a new v3 _add_user_audit.sql migration script to add 2 new columns to the book table. Ensure you type 2 underscores after the version number.
Listing 12.24. Adding new audit metadata to the book table.
During the application startup, Flyway will automatically go through all the migration scripts and apply those not yet applied. The trade-off of enforcing backward-compatible changes is that we now have to treat as optional 2 fields that we need to have always filled in, and that may possibly fail validation if they're not. That is a common problem that can be solved over 2 subsequent releases of the application. 1. In the first release, you add the new columns as optional, and implement a data migration to fill in the new columns for all the existing data. For Catalog Service, you could use a conventional value to represent that we don't know who created or updated the entity, such as unknown or anonymous. 2. In the second release, you can create a new migration to update the schema safely and make the new columns required. I'll leave that up to you if you'd like to do that. If you're interested in implementing data migrations, I recommend that you check out Flyway's official documentation, flywaydb.org. In the next section, you'll see how to test user-related auditing in Spring Data JDBC. Section 12.4.2, Testing Data Auditing with Spring Data and with Mock User. When we test security at the data layer, we're not interested in which authentication strategy has been adopted. The only thing we need is to know whether the operation is performed in the context of an authenticated request. The Spring Security Test project provides us with a handy with mock user annotation we can use on test cases to make them run in an authenticated context. You can also add information about the mock user. Since we're testing auditing, we want to define at least a username that can be used as the principal. Let's extend the book repository JDBC tests class with new test cases covering data auditing for users.
Listing 12.25. Testing data auditing when users are authenticated or not.
Open a terminal window, navigate to the Catalog Service root folder, and run the newly added tests as follows.
See this code?
If you experience any failures, it might be because you haven't updated the test cases where the book constructor is used. We have added new fields to the domain model, so remember to update those test cases as well. Section 12.4.3. Protecting user data with Spring Security and Spring Data R2 DBC. Similar to what we did in Catalog Service, this section will show you how to add data auditing for users in Order Service. Thanks to the abstractions provided by Spring Data and Spring Security, the implementation will not be much different, even though we're using Spring Data R2 DBC and Reactive Spring. Besides data auditing, Order Service has one additional critical requirement. Users should be able to access only their own orders. We need to ensure the privacy of all that data. This section will also walk you through the changes necessary to accomplish that result. Defining an auditor to capture who created or updated an R2 DBC data entity. Even in this case, we need to tell Spring Data where to get the information about the currently authenticated user. Since it's a reactive application, this time we'll get the security context object for the principal from the reactive security context holder. In the Order Service project, Order Service, open the Data Config class and add a reactive auditor aware bean to return the username of the currently authenticated user.
Listing 12.26. Configuring user auditing in Spring Data R2 DBC.
Adding audit metadata for users who created or updated an R2 DBC data entity. When a reactive auditor aware bean is defined and auditing is enabled, Spring Data will use it to extract the username of the currently authenticated user represented as a string. Even in this case, we can use created by and last modified by to annotate 2 new fields in the order record. They will be populated by Spring Data automatically whenever a create or update operation is performed on the entity.
Listing 12.27. Fields to capture user audit metadata in an R2 DBC entity.
After adding the new fields, we need to update a few classes using the order all args constructor, which now requires you to pass values for created by and last modified by. The order service class contains the logic for updating dispatched orders. Open it and change the build dispatched order method to ensure the audit metadata is correctly passed along when calling the data layer.
Listing 12.28, including the existing audit metadata when updating an order.
I'll leave it to you to update the auto tests in a similar way. You can also extend the tests in order JSON tests to verify the serialization of the new fields. As a reference, you can check Chapter 12/12n/order service in the code repository accompanying this book. Ensure that you update the tests using the order constructor, or the application build will fail. Writing a flyway migration to add the new audit metadata to the schema. Similar to what we did for catalog service, we need to write a migration to update the database schema with the two new fields hosting the usernames of who created an entity and who modified it last. In the src/main/resources/db/migration folder for the order service project, create a new v2-add_user_audit.sql migration script to add two new columns to the orders table. Ensure you type 2 underscores after the version number.
Listing 12.29, adding new audit metadata to the orders table.
Ensuring user data privacy. There's one last requirement we haven't covered yet, ensuring that order data is only accessed by the users who created the orders. No user should be able to see the orders from another person. There are a few different solutions for implementing this requirement in Spring. We'll follow these steps. -1. Add a custom query to order repository to filter orders based on the user who created them. 2. Update order service to use the new query instead of the default find all. 3. Update order controller to extract the username of the currently authenticated user from the security context and pass it to order service when asking for orders. Warning: we'll rely on a specific solution that ensures each user can only access their own orders via the /orders endpoint. However, this won't prevent developers from using the other methods exposed by order repository in the future and leaking private data. If you'd like to know how to improve this solution, refer to Chapter 17 of Spring Security in Action by Laurentiu Spilka, Manning, 2020. Let's start with order repository. Using the conventions you learned in Chapter 5, define a method to find all orders created by the specified user. Spring Data will generate an implementation for it at runtime.
Listing 12.30, defining a method returning orders created by a user.
Next, we need to update the getAllOrders method in order service to accept a username as input and use the new query method provided by order repository.
Listing 12.31, returning orders only for the specified user.
Finally, let's update the getAllOrders method in order controller. As you learned in the previous chapter, you can auto-wire an object representing the currently authenticated user through the authentication principal annotation. In Edge service, the object was of type OIDC user because it's based on OpenID Connect authentication. Since order service is configured with JWT authentication, the principal will be of type JWT. We can use the JWT, an access token, to read the subclaim containing the username for which the access token was generated, the subject.
Listing 12.32, getting the username and returning only orders created by them.
That's it for order service. In the next section, you'll write some auto tests to verify the data auditing and protection requirements. Section 12.4.4, Testing Data Auditing and Protection with Withmock User and Spring Data R2 DBC. In the previous section, we configured data auditing for users and enforced a policy to return only the orders for the currently authenticated user. This section will show you how to test the data auditing as a slice test. To verify the data protection requirement, you can refer to the repository accompanying the book and check how it's been covered by the integration tests in the Order Service Application Test class, Chapter 12/12n/Order Service/src/test/Java. Data auditing is applied at the repository level. We can extend the Order Repository R2 DBC Tests class with extra test cases covering the scenario where the user is authenticated and when it is not. Similar to what we did in catalog service, we can use the with mock user annotation from Spring Security to execute a test method in an authenticated context, relying on a mock user representation.
Listing 12.33. Testing data auditing when users are authenticated or not.
Open a terminal window, navigate to the catalog service root folder, and run the newly added tests as follows.
See this code?
If you experience any failures, it might be because you haven't updated the test cases where the order constructor is used. We have added new fields to the domain model, so remember to update those test cases as well. That concludes our discussion of authentication, authorization, and auditing for both imperative and reactive cloud-native applications using Spring Boot, Spring Security, Spring Data, and Keycloak. Polar Labs. Feel free to apply what you have learned in the previous chapters and update catalog service and order service for deployment. 1. Update the Docker Compose definitions for both applications to configure the Keycloak URL. You can use the container name, Polar Keycloak 8080, which gets resolved by the built-in Docker DNS. 2. Update the Kubernetes manifests for both applications to configure the Keycloak URL. You can use the Keycloak service name, Polar Keycloak, as the URL, since all interactions happen within the cluster. You can refer to the Chapter 12/12n folder in the code repository accompanying the book to check the final results. See this link. You can deploy the backing services from the manifests available in the Chapter 12/12n/polar deployment/Kubernetes/platform/development folder with kubectl apply-f services or the entire cluster with /create cluster.sh.